You're playing your favorite racing game and your biker is just about to win. But suddenly, his bike hits a wall. And you might have guessed what happens next. Yup, he flies out ahead. It's not just in games that this happens. Things like this happen in real life too. The question is why? Why did the biker fly ahead when his bike hit the wall? To explain situations like these and understand motion better, the great scientist Sir Isaac Newton proposed three laws of motion. These three laws revolutionized the world of physics. We'll learn them one by one. But first, in this session, we will learn about the first law of motion. The first law of motion has two parts. The first part says that a body at rest stays at rest unless an external force is applied. We can verify this easily. Say we have an object like a mobile phone. If we keep it at rest on a table, it'll stay at rest and won't move unless someone tries to move it. Simple logic, right? But there's more to the first law. The second part says that a body in motion stays in motion unless an external force is applied. Now, this part looks suspicious. How can a body stay in motion forever? If I take a ball and roll it on the ground, it doesn't keep moving forever and stops after a while. That means there are only two possibilities. Either the law is wrong or there is some external force that makes the ball stop. Is there a force that makes the ball stop? You might have guessed it. Yes, the external force is friction. You must have studied about it before. Because the ground is rough, it applies friction or frictional force on the ball. And it's because of this frictional force that the ball stops. What would happen if we reduced the amount of friction by using surfaces like ultra smooth glass or ice? Yes, the ball would roll for a much longer time. And if we could remove friction entirely and make it zero, what would happen to the ball then? Yes, the ball would keep on rolling forever. Can you even imagine a world without friction? Simple things like walking or even stopping a vehicle would become extremely difficult. There would be chaos everywhere. Coming back to the law, we learned that a body in motion stays in motion unless an external force stops it or changes its speed. But friction makes it difficult for us to experience this. And what does that mean? Yes, the first law of motion is correct. Sometimes the first law is also defined like this. A body at rest stays at rest, and a body in motion stays in motion with the same speed and in the same direction unless an external force is applied. We know that the speed of an object does not change unless a force is applied. But does same direction also make sense? Yes. The direction of an object will also not change by itself. A force is needed to do that, right? Hope you now understand the first law statement. With a little bit of practice, I'm sure you'll be able to narrate it yourself. Try doing that after this session. Let's go back to our first question. Why did the biker fly out after the collision? Upon collision, the external force applied by the wall changed the motion of the bike and stopped it. But no force or a lesser force acted on the biker. And so his tendency was to stay in motion. This made his body detach from the bike and he flew ahead. Yup, poor guy. Sometimes people use the first law of motion to define force as well. A force is also stated as an external cause which can change the state of rest or motion of a body. Makes sense, right? Hope you understood the first law of motion and enjoyed this session. Let's recap what we learned today. Newton's first law of motion states that a body at rest stays at rest, and a body in motion stays in motion with the same speed and in the same direction unless acted upon by an external force. We learned that in the absence of an external force like friction, a moving object will keep moving forever. We also used the first law to define force as an external cause which can change the state of rest or motion of a body. That's all for now. I'll see you next time. Till then, keep learning.